My name is Bill Zimmerman. Your dealer and the Ford Parts and Service Division are pleased you're watching this videotape. We will be talking about some common causes and corrections of automobile noise, vibration, and harshness, often referred to as NVH. We'll be looking into three specific vehicle areas where NVH commonly occurs: wheels and tires, the driveline, and the engine and its accessories. We'll be discussing common NVH problems that occur in each of these three areas and which account for about 90% of all customer-related complaints. We'll be highlighting basic procedures for diagnosing and solving NVH problems. I suggest you refer to your Vehicle Vibration Diagnosis Guide for greater detailed information and as a ready reference aid when servicing an owner's vehicle. When diagnosing NVH problems, it is first important to determine the normal level of smoothness for the car being tested. Your customer should understand that some noise and vibration from mechanical movement is always present in every vehicle and varies due to vehicle environment such as size and weight. As a professional NVH service technician, you should become aware of the various behavior characteristics of each model you work with. Knowing what is considered to be normal, noise, vibration, and harshness, will help you determine what is not normal and needs to be corrected. Remember, most owner NVH complaints are related to the vehicle in motion. This means that you must always conduct a complete road test to personally experience and isolate the condition yourself. Incidentally, we know your early morning hours are very busy, so try to arrange a road test appointment with the customer at a mutually convenient time. As you check the vehicle for owner complaint, record all the results on a Vehicle Vibration Diagnostic pocket card to help further isolate the specific NVH area that's causing the problem. There are general road testing procedures that apply to all NVH complaints. For example, prior to any road test, always connect a tachometer. It's important to know at which engine speed and road speed the NVH problem occurs. Some technicians set the correct tire pressure before every road test. However, other NVH technicians prefer to road test the vehicle with the same tire pressure as the owner used. Either method is acceptable as long as you follow the same procedure before every road test. Always road test the vehicle with the customer. This is the best way to isolate the customer's complaint. During your road test, try to find a smooth road surface where maximum speeds are allowed. Concentrate on the specific owner complaint during the road test, getting all the objectionable symptoms from the owner's point of view. Remember that some types of NVH may only occur on certain road surfaces that are driven on by the customer. After the road test with the owner, find out as much as you can about the problem. Find out when the problem occurs, at what speed, in which gear. Did the problem originate when the car was new, or did it happen recently? Get as much owner information as possible, because talking to the owner is one of the best ways to help you diagnose and isolate an NVH problem. Now that we've reviewed some basic NVH background and the importance of a complete road test, let's first look at NVH problems associated with wheels and tires. Noise and vibration problems with tires and wheels occur because out of round or out of balance wheel assemblies try to alternately lift off the road surface and slam down on the road surface. This lifting and slamming of one or more wheel assemblies can be clearly felt by the driver and passenger. In severe cases, the hood and fender sheet metal can even be seen to vibrate. We can say that 4 distinct conditions are associated with out of balance or out of round wheels or tires: a definite pattern of vibrations, a shaking or vibrating of other components. The vibrations are always present to some degree at all speeds. Some tire unbalance may be a problem at higher speeds. Your job is to determine if the NVH problem is actually caused by wheels and tires, by the driveline, or by the engine and its accessories. Proper road testing of the vehicle will help you find and isolate the exact cause. Here's how to road test for NVH problems related to wheels and tires. Operate the vehicle in the speed range where the vibration occurs. And then accelerate to 10 miles an hour above this speed. Place the transmission in neutral and coast down through the problem speed range. If the vibration is clearly felt, then the problem is probably being caused by out of balance or out of round wheels or tires. Once you've determined that the problem originates with the wheels or tires, proceed as suggested under Section A of the Vehicle Vibration Diagnosis Guide. That is, check the tires and wheels for lateral and radial runout. Before measuring a wheel assembly for lateral or radial runout, check the tire for misalignment wear marks like cupping or scalping. Also, spin the wheel and listen for rough bearing noise. If either of these conditions are present, they could be causing the out of balance condition. Eliminate these possibilities before checking the wheel and tire for lateral and radial runout. When you check a wheel for a lateral or radial runout, be sure the dial indicator does not contact the extreme edge of the wheel, because this position will not give an accurate reading. To measure wheel radial runout, place the indicator stem against the flange of the wheel. The indicator stem is now placed in position for measuring lateral runout. If either radial or lateral runout exceeds 45 thousandths of an inch when the wheel is spun, the wheel must be replaced. Here we are measuring for tire lateral runout, and we see the dial indicator stem positioned on the smoothest surface outside the wear rib. If the tire lateral runout exceeds 70 thousandths of an inch, the tire must be replaced. For bias ply tires, radial runout is checked with the dial indicator placed at the center of the tire tread. Radial runout for radial tires should be checked on the inner and outer tread ribs, noting the highest runout reading for either of the ribs. If the tire radial runout exceeds 70 thousandths of an inch, we have come to our next step on the vehicle vibration diagnosis chart, which is to re-index or replace high runout wheels and tires. Re-indexing the wheel and tire assembly may be necessary to bring the wheel and tire assembly back to specifications, which is 70 thousandths of an inch or less. Remember to line up the high spot on the tire with the low spot on the wheel. Once the wheel and tire assembly has been brought into acceptable specifications, we're ready for our final step in Section A on the vehicle vibration diagnosis chart. You will now want to balance all four wheel assemblies using an on-the-car balancer or strobe light balancer. You've probably learned through experience that proper wheel balance may be the most important procedure for correcting most NVH complaints. You also know that good equipment is a must, especially when balancing steel-belted radial tires, which often require balancing to 1/4 ounce or less. Remember also that tires can be out of balance in 2 directions. This means, of course, that wheel assemblies can be out of balance up and down and side to side. Proper wheel balancing requires that the entire wheel assembly be balanced in both directions, and this means balancing for up and down and side to side. If you find a major problem with a tire before or after wheel balancing, be sure to personally contact the local representative for that particular brand. Tell them exactly what you did to try and remedy the tire problem and why you think the tire should be replaced. Use the tire replacement request form when attempting to get a tire adjustment from the tire dealer. It's simply poor customer relations to ask the owner to do the job of replacing 1 or more tires. The owner deserves to have the NVH problem completely taken care of at your dealership. Sure, we know the tire warranty is the responsibility of the tire manufacturer, but the owner and his or her car is your responsibility. The owner has already done her job by bringing her car back to your service department, and trust your ability to fix the problem. Don't expect an owner to do more than that. Remember, if you do send an owner back to a tire store, a number of negative things could happen. The owner could be sold services she doesn't really need, like ball joints or premium tires. And this would turn a minor inconvenience for the owner into a major and unnecessary expense. Worse yet, you could lose that owner as a regular customer. Now let's look at the positive side. If you take care of an NVH problem, as you should, at your dealership, you earn the owner's appreciation and more. More than likely, an owner will show you her goodwill by servicing her car in your dealership on a regular basis, by buying replacement parts and accessories in your parts and service department, and by coming back to your dealership when it comes time to buy a new car. In short, do your very best to solve an NVH problem in your service department. The owner will appreciate your helpful attitude, and our mutual goal of no unhappy owners will be one step closer. Our next area of investigation in solving NVH problems centers around the driveline. Because of the location of the driveline between the vehicle underbody and the road surface, and because of relatively large size of the driveline, the effect of driveline unbalance will be quite different than the effect of wheel and tire unbalance. Since the driveline is located close to the floor pan, the pan tends to move with the driveline. This movement of the driveline and nearby sheet metal acts like a drum. We can see that an unbalanced driveline can cause an objectionable condition that is often described by the owner as a drumming or booming sound. Road testing to isolate driveline unbalance or misalignment involves about the same procedure used to isolate wheel and tire balance problems. Operate the vehicle at a road speed where most of the disturbance is present. Then, increase the road speed about 10 miles an hour. Place the transmission in neutral and coast down through the problem's speed range. If the disturbance is basically unchanged, it means wheel and tire problems. If the disturbance is eliminated or substantially reduced, there's a driveline problem. While road testing for possible driveline problems, remember to use a tachometer and note the corresponding engine speed to the road speed. You are now ready to proceed as indicated under Section B of the Vehicle Vibration Diagnosis Guide, which reads, raise the vehicle on a twin post hoist or jack stands. Remove wheels and operate the vehicle at the problem speed. If vibrations occur, proceed with the following. The purpose of operating the vehicle without the wheels is to further isolate the driveline problem. If vibration does occur at the same engine speed noted during the road test, the problem is definitely with the driveline because no wheels or tires are present to cause vibration. As listed in section B and C of the Vehicle Vibration Diagnosis Guide, driveline NVH problems can involve a driveline alignment or runout check, a driveline balance check, measuring companion flange runout, and measuring the pinion angle. Let's review the two most common driveline diagnostic areas. First, let's look at driveline alignment or runout. A driveline runout check will also tell you about the condition of other related components, like the U-joints, companion flange, and drive shaft. When isolating the problem to driveline alignment, check the drive shaft runout at each end and at the center of the shaft. Maximum allowable drive shaft runout is 35 thousandths of an inch. Sometimes a drive shaft that shows slightly more than 35 thousandths of an inch runout can be brought back to specifications by rotating the drive shaft 180 degrees on the companion flange. If this doesn't correct the drive shaft to specifications, the drive shaft will have to be replaced. The second most common driveline diagnostic procedure is to balance the drive shaft. The procedure for drive shaft balancing is to mark the rear of the drive shaft in 4 separate sections by using the numbers 1, 2, 3, and 4 as you see it being done here. Equally space the numbers around the drive shaft circumference. Install a hose clamp with the screw of the clamp in the number 1 position. Operate the vehicle in the vibration range and evaluate the drive shaft balance. Repeat the evaluation with the clamp screw in each of the 3 remaining positions. Secure the clamp in the position that best corrects the driveline unbalance. Yes, driveline runout and driveline balance diagnostic checks are the most common methods of diagnosing and fixing driveline NVH problems. The other 2 checks you may occasionally encounter when diagnosing driveline NVH problems are for companion flange runout on the double cardan U-joint or companion flange runout on the standard U-joint. A second method for measuring companion flange runout on the standard U-joint is described in the Technical Service Bulletin number 38. And finally, driveline vibrations can sometimes require a pinion angle check with use of a special magnetized bubble gauge as you see it here. The complete procedures for making the various driveline diagnostic checks are fully described in your Vehicle Vibration Diagnosis Guide. Refer to this helpful booklet often when diagnosing driveline problems. Our final area related to NVH problems involves the engine and accessories. Vibration in this area can be diagnosed rather easily because they do not usually vary with road speed. Of course, road testing is necessary to isolate the specific engine or accessory NVH problem. Engine and accessory noise can sometimes worsen with increased engine speed. While road testing, run the vehicle at various road speeds to note the objectionable noise. If the unusual noise is eliminated by changing road speeds, the problem is most likely caused by the engine or one of its accessories. Be sure to refer to section D and E in your Vehicle Vibration Diagnosis Guide for complete engine accessory check procedures. Common engine and accessory NVH problems can include vibrations in the accessory driveline system. When this occurs, inspect for broken or frayed belts. Checking accessory belts for the proper tension can also uncover and eliminate engine area noise and vibration symptoms. Sometimes an air conditioning or power steering hose will vibrate against inner body panels or other under the hood components. These hoses should be adjusted and rerouted properly. Loose bolts, such as this one on the air conditioner bracket, should be torqued to specifications listed in your shop manual. Other engine accessory NVH problems can be caused by loose or misadjusted power steering pumps or water pumps. Often, an abnormal vibration will be caused by a loose or mispositioned engine mount. Follow the procedure in the Vehicle Vibration Diagnosis Guide for neutralizing loose engine mounts. Grounded or abnormally strained exhaust system components can also cause noise and vibration problems. Reposition all exhaust system components and hangers as necessary to eliminate this type of owner complaint. Always neutralize the system when it's hot. We've looked at the 3 common areas where most NVH problems can occur. In summary, if you diagnose each owner complaint carefully, you should have little difficulty in isolating the problem component and arriving at the right fix in a minimum amount of time. Remember, before tackling a vehicle NVH problem, always conduct a road test with the owner. The owner can help you isolate the problem to the wheels and tires, the driveline or companion components, or the engine and its accessories. Refer often to the Vehicle Vibration Diagnosis Guide when servicing a vehicle for NVH problems. For additional assistance, refer to Technical Service Bulletins number 38 and number 56. As you perform the various diagnostic tests and procedures, keep track of your progress by using the handy Vehicle Vibration Diagnostic Pocket Card. Your owners are important people. They depend upon your professional skills to expertly service their automobiles and correct their NVH problems. Every owner's goodwill can mean future new car sales and service department business. Treat your owners right, and they'll treat you right. Let's all keep working toward our mutual goal of no unhappy owners.